Hello and welcome back to compiler programming. It is time for us to actually start writing out some bytes to disk and see how it works out. As a first step, what I will do is I will basically just take some of the bytes that we see in the executable that we created in minimal.exe, and then I will start to try to emulate them and write them out to disk, then open a hex editor and see that we are doing the right thing. Now, luckily for us, there is actually a definition of all of the structures that are involved in creating a portable executable. They are defined in winnt.h, and here you can see the full path to this stuff. The version changes depending on probably based on the Windows version, but in general it will be somewhere in that neighborhood, and you can open the file, or if you use an IDE, you can probably just type in the name of this struct and jump to the definition of it. So nothing really complicated there, and there is a pretty good explanation about what all those fields do, and this is exactly what we're gonna start with. So I will refer to this stuff from here, and I will simply just create a function that will be something like, for now, very straightforward. I will do void write executable, and we will, for now, it will not even accept anything. I will just try to write out that minimal example as we have it, and then step by step we will start working on wiring up our code compilation into that example. But for now, let's just make sure that our data structures are set up correctly, that our code is able to do what it needs to be doing, and everything is working. And I'm not even sure we can get to that point today, but at least we will be starting on it. Okay, so here's our type definition. I just put it here because we will need to use some of the fields, and it's handy to have a reference in front of you when you do that. Okay, so now I say image dos header. Dos header is what? Well, magic is something we definitely need to set, and we might even have the correct thing. Yes, so I can use image dos signature from here. So this is magic. I don't think we need much of other stuff, so let me open Pepper and see if I need to do anything else. So this is our ms-dos header, and as you can see, these are the fields that we are looking at. So bytes on last page of file. So it actually has some value here. Pages in a file, that's also very interesting. Relocations is 0. Size of header in paragraphs. Who knew what that means? Min alloc, max alloc. Okay, we can write this out. I think that's the register, but I'm not sure. Stack pointer, maybe? Would be nice to have more information on this. Checksum, instruction pointer. This is a code segment register. File address of relocation table. So that's interesting that we are using this. And then a bunch of zeros, and then we have ELFA new, which is new exe header. And then there is a bunch of stuff for this program that sort of, yeah, it starts in here, I guess, and till, let me zoom in so it's easier to see. And then till the end, it is a stub program, and I think we're literally gonna copy it verbatim because I don't want to do anything special to handle this stuff. And then at C8 we have the start of actual portable executable header, which we'll deal with next. But this stuff, I guess I will literally just copy. Let's see if it copies. Okay, well, sort of. It will be a bit annoying to turn this into a hex string. Well, let's use a bit of JavaScript, I guess. Let me open another terminal. And let's open Node. Let's do this, and then we do split on, how would it look like? Well, I guess what will that yield? That is not exactly what I wanted to. Maybe if I use, so this is better, but still not what I want. What would be the best way to format this number into what we want? Not even sure. Okay, whatever. For now, we can just keep it as a comment, I guess, and then figure out later what this needs to be. Okay, let's start to fill in the fields. Magic, image dust signature, CBLP 90. Bytes on last page of file. I guess that might be the size of this stuff. So it starts at 40 and it ends at C7. So let's bring out the calculator. We need, I guess, programmer one, and we say C7 minus 40 is 87. That does not look like 90 to me. Okay, I'm not sure what that thing does. So for now, we will just copy it as it is and add a comment that we have no idea what it actually means. Okay, let's continue. Pages in file. Well, the same thing. I have no idea what that means, but for now it's probably not important. I don't think that Windows actually looks at these besides when it executes this program, and since we are never going to touch this program again, we can just ignore what it does. If you're curious, probably you can look up deeper what those headers actually mean, but for now it is fine. Okay, we have cp arc dr, and that looks like, okay, so it's size of header in paragraphs, but that's okay. Well, let's try to do this, and the same here. Let's see. Max alloc, so min alloc will be 0 by default, but maybe it is worth to say 0 explicitly. The max alloc, that's gonna be like so. That's okay. ESP is 0B 0x B8, and that is initial stack pointer value. Okay. What else do we have? We have this LFA relocation, I guess. Yeah, file address of relocation table. That's very interesting because I don't think we have one. Okay, so this thing here is actually relocation table. Okay, well, that's fine, I guess. So we do need to put it in. ELFA relocation. Is there a header for DOS relocation table? Doesn't look to be the same. I don't think there is one. I think this is just for Windows executables, all the information. Yeah, I don't think we have more details about how this works. Okay. Let's continue. ELFA relocation, that's fine, and that should be there x40. And since I don't know how to interpret this stuff, I don't really know like where does a relocation table stop and where does the actual code begin. I guess we could try to look at the instructions, but they are those instructions, so they are 16-bit, I think, and I'm not even sure how to read this assembly. So, okay. Let's move this down a bit. We have relocation table, and then we have ELFA new, which is C8. So this is file address. I can copy from here. File address of relocation table. I'm missing a comma. And ELFA new, this is what actually tells us where is the like the address of portable executable header, which is the real thing Windows uses to figure out how executable is structured. And this is going to be 0x C8. Now, I think we might want to turn this to 0 if we try to open it in Pepper. I actually don't know what will happen when we give it invalid executable, like how much it will not like us for that, but we will see. Okay, we do need to create a buffer. So we say file buffer is, I think it's called make buffer. Let me open this stuff here. Buffer, buffer. I guess it's not in the header. Yeah, we should put it in the header file as well. That's just good practice. Okay. So it is make buffer, capacity, and permissions flag. Good. And we can check in our main code how we are actually using this. I guess, or in here. That looks good. We can use that and go back into here. So buffer, exe buffer is 1 megabyte. That will be plenty for now. We can figure out resizable buffers later. Okay, exe buffer, and actually what we want to do is we want to say exe buffer or buffer allocate of exe buffer and image does header star does header is like so. Image does header, and then we write to that memory. We could also just start writing out bytes as we create them, but I'm pretty certain at some point we will need to actually patch some stuff around the same way as we do when we deal with instructions, and it is easier to do if you have it all in memory instead of just jumping through the file stuff. So now we need to write this out, and since this is Windows stuff, I think I also want to use Windows file functions instead of libc, like freed and fwrite, because eventually we want to create executables that are also don't depend on libc maybe, and it would be nice to use this. And honestly, I don't know libc stuff good enough anyway, so let's just do write file. So msdn write file. And there is even a nice example of opening file for reading and writing. Essentially, you just do create file, and then you write there. That's pretty straightforward. There is a bunch of error handling. We can skip it for now, but the rest is pretty fine. And the good thing is it just accepts a buffer, so nothing really fancy there. Okay, so we can copy this code and start figuring out how we're gonna use it. Name of the write. I don't know if supports relative path. I guess it should. Well, let's try to say build and then test exe. Okay. No, that's fine. Create new file only. Actually, I probably want to overwrite as well. So we should look at create stuff, and here there is access mask, and no, that's not what I want. Generic read, generic write. Yes, that's not what I want. And okay, so I think we want open always, so it will create always is by function overwrites the file. Okay, no, we want create always. Okay, it's a normal file and nothing fancy there, so that's fine. I don't like that alignment, so let me fix that very quick. Okay, like so and like so. Okay, so this is create file, and we need to assign it to a file handle, which is just handle. Handle file is this stuff. Then we, oops. Whatever. I'll fix the alignment later. If file is invalid handle file, I don't have display error stuff, which apparently is some kind of external function. So let's just, we'll just assert for now. That will be okay. So let's include asserted h. Okay, file is not an invalid file handle. And now we can write some stuff to that file. So we do write file. And at the end, we will need to close the handle. Otherwise, it will stay open. I think the handles are cleaned up when you exit the executable, but I'm not sure. Here we need to point to exe buffer dot memory, and then this thing returns bytes written. We need to pass a location where it will say how many bytes it's wrote to the file. So say address of bytes written. Its bytes to write is exe buffer occupied. We'll probably need to cast a bunch of these stuff because of incompatibilities between what types I'm using and what Windows expects. Okay, I think we can get rid of this stuff. And we have write executable. Now we have these gigantic things that we still need to figure out. But for now, I will just ignore that stuff. And I will write just the DOS header and till error and see if those bytes match what we are actually expecting. Okay, let's see if this builds. Something does not work out. Yeah, okay, Pepper has open minimal, so it actually doesn't work. It really sucks that it holds the file handle. What should I do? I guess the easiest thing, since I want to have it, is to copy it somewhere else. And then I will open that copy in here. So this is awkward. Okay, I will put it in here. And now we can probably correctly build our stuff. Syntax error. Yes, you don't know what the type of this object is. That's okay. I can teach you. Yeah. Okay, it wants Unicode stuff. That's a separate topic altogether. And as I said, we'll need to convert a few types. So it wants a D word. Good. Let's actually call this function because we are not really calling this. For now, I will just stick it into one of the tests. So say it should write out an executable. Just like so. Now when we run tests, something should happen. Okay. It didn't explode, so something did happen. The question is it something that we wanted to happen? Okay. We do have test.exe. I will not even try to run it. It will do bad things. And essentially it will, actually let's try, but I think it will just crash crazily, or it will say it's not, actually Windows will say that it's not a valid executable. Yeah, it's incompatible with 64-bit version of Windows because it only has a DOS header. But that's okay. I do want to try to open it in the Pepper program and see if it can handle it. Okay, so that's good, I guess. It opened something and we can compare our stuff here. Be nice. Can I open like 2 of them? Okay. Such an awkward thing. It's like, why are you holding the pointer to it? Handle. Okay. So let's just do very quick visual compare and see if we are doing it right. So far it looks to me like we are doing okay. We have everything like this, then 40, and then stuff. So this actually looks pretty good. And we have it up till 3C. So yeah, this row is all okay. So this is till when we have our struct have worked, we can write it out. Everything is great. Okay, how do I split you? Well, I guess we need to write a yes, let's go back to our JavaScript stuff, and there is some way to enable copy paste correctly. Should it work? Don't know. Okay. So we have this stuff, and we can say I don't want to split, but I do want to do something about it. So maybe I actually do want to split it on like this. So we have individual like half bytes. And then we want to format this nicely. Maybe there is actually, maybe other programs do it slightly better. Whatever. We can do reduce, we can say byte, and then we have, so this is going to be accumulator, then we have a actual letter, and then we have index, and I can say that we pass an array, and if we what? Maybe that actually would be easier to do in the console of a browser. So we can have nicer formatting stuff. So split, reduce letter, and I say I percent 2, then egg. There's probably an easier way to do it, but I'm just trying to figure out what I can. So egg length. So basically the idea is if it's a even number, we put it in the last item, otherwise we create another item. So we say push we need to return accumulator here. Otherwise we just put letter and then we push letter. I thought that was correct. Am I misremembering how reduce works now? That's interesting. Well, yeah, accumulator and then current value. So we have accumulator, current value, and this is the accumulator. Yeah, there is. So the problem is the condition is wrong. I guess. Or it should be other way around. Actually, yeah. It should be push letter. Okay, that looks closer to what I want. If we open one of them, we see that it's actually correct. And now I can do map x join and then 0x plus x join. Okay. And then I can do join comma. Great. So that took a bit of trying, but I can finally do this. Const s8 what we'll call it DOS program bytes, and we're just gonna format it somehow. It doesn't really matter. Okay, good. So we have this stuff, and we can also append it to our executable. Where would it happen? I guess after here. So we say s8 star DOS program bytes is buffer allocate exe buffer size of this stuff. And then we want to mem copy, which I don't remember how it looks like. So see mem copy. test source count. Great. So test is those program bytes, source is the same but like this, and the size of those program bytes. That sounds good to me. Let's try to build this. And it should be buffer allocate size. I'm missing a semicolon. I can fix that. And we're good. Let's exit this stuff and run our test again. We have the same problem that this thing cannot really output stuff, but now we can, and we can compare our DOS header much better. Okay, so this is our new one, this is our old one, and we could probably find a diff, binary diff thing for the next episode, so we can compare it not just visually but more precisely. The cursory inspection looks good to me, so if I make it the same size, we can see that 0C answered the right thing, and then it said like here we already start with the P header, and this is this stuff, I think. Okay, that actually is not that. There is this rich header, whatever this is. So I guess we could deal with it separately, but it's fine. 090. Interesting that even though we have all of this information, it doesn't get picked up by the program, but we will debug that later, because as far as bytes goes, it looks the same to me, at least. So I'm not sure. Okay, that is good. Now we have the NT header, and this is gonna take a bit more stuff for us to actually make it work. The first thing we need to write out is the signature, and I think it is available somewhere here where we say that we actually want 64-bit header. Maybe not. What is the actual value of it? It is so if it is Little Indian, it's 4550. Okay. Okay. So it is image NT signature. So I guess it is always the same. The same thing. Okay. So we can write out that. That's very easy. We just say that we add a bit of separator here, so I know where we're creating file versus where we're writing. Maybe we can turn it into two functions, but for now, that's fine. So we say S32 NT signature is, or even easier, buffer append S32. I guess that's how the function is called, but we can check if it's not, and I can do it like this. Okay, so this will add 1 more byte to our file, or actually 2 more bytes, or 8 bytes. It's a 32-bit value. And then after that, we have the actual image file header. Okay, we can look at that as well. Image file header. Where are you? Image file header. Here you are. So this is what we will need to write out. And I can copy this setup over here where we allocate it in the buffer, and then we just put on some fields to that header. And we can even look exactly which fields we want. Good. So we say machine is, I want to copy this from here because it should be somewhere, yeah, image file machine AMD x64, like so. So we are writing a 64-bit executable. Now, number of sections, these might actually be different later on in our setup, but for now, so that files are exactly the same, sorry, I will actually just copy this. So number of sections is gonna be 3, or I can just do 3. Doesn't have to be a hex number. Time date stamp probably can be 0. Pointer symbol table 0. Number of symbols 0. We are not writing out an object file, so that's why I think it's 0. Size of optional header. This is the size of image optional header 64, I believe. So we can try to put that there and see if the number of bytes actually matches. So we say size of optional header is 0, or actually size of, and then image optional header 64. Okay. And characteristics. This is something interesting because I think these are flags that we will need to look up. I guess some of these are the characteristics. So let's try to do this. We say mstn image file header. I'm not sure if it will give us more information. Actually, it does. So what are those things? Firstly, the number that we are looking for is 022. So it is an image file, executable image. That seems important for us to put into there. And it makes total sense. So this is an executable file image. And what else is it? So these two here, image file large address aware. Well, we are a 64-bit executable, so it makes sense that we are large address aware. Obviously, this is not a DOS header. This is a file header, and this is a file header. Okay, we can get rid of this stuff. Try to build things. And it builds just fine. I will need to close this file, do test, open this file again, and see how we're doing. Okay, so we got further. This thing actually works just fine, but it does not actually open the header, but we can still look at it if we open the hex stuff directly. Because this is this p signature, and here it is here. So this works just fine. And then if you look at the rest of the bytes, this timestamp I don't care about. So it is 0. I guess I should just hard code it for now, because again, if we were going to be using some kind of I cannot copy you. Oh, that sucks. Yeah, I also need to flip the bytes because it is little Indian. So what was it named? Time date stamp. Time date stamp is this stuff. So yeah, I need to switch around the bytes because it's a little Indian architecture. Generate ourselves. Okay, so this is the difference here, and then we have 0f22. So yeah, I was right. This size of optional header is literally size of optional header. Okay, I think this is a good start. The rest of the header stuff will happen in a different video, because if we look at what is going to happen there, then we need to start dealing with the sections and their alignment and file alignments and so on and so forth. I think the actual data structure I will do a video, because there is nothing interesting. It's just literally copying values from one file to another like we did for other two, but I will not do the section stuff, or maybe I will leave it for the other video as well. I don't know. Let's see. But to not drag this for too long for today, that will be it. We are finally starting to write out executable, which is pretty nice. And hopefully I'll see you in the next video where we continue our work. For now, goodbye.